Assalamu alaikum. So this video is on finding the impulse response using cross correlation, and for this task we will use MATLAB code. So we have a system here. You see this is a system. This is actually a difference equation representing a system. So I have to find the impulse response, that means H, from this system. Okay, so to do this, first I will take the help of a noise. This is a white noise, and then I will find Y, and to find the impulse response we have to use a cross correlation, and this is the impulse response. This is the approximate impulse response. So it is actually true or false, we have to verify this. So in the end of the video we have verified this. Yes, this is our impulse response, our code is right. Okay, so let's first dive into our code, dive into the theory. So what is the theory behind? So the theory is, let's say you have a system whose impulse response is Hn, and you have to find this Hn. So if you input some signal, if you input something, then you will get some output which is equal to Hn convolution of Xn. And now let's say you have input a noise, you have give input and noise to the signal, which I represent here by R, or R can be written as random numbers. Noise are random, so R means random numbers. So if you input R to the system, then Yn will be is equal to Hn, and now X is equal to R. Okay, now let's take a cross correlation function R between Y and R. That means Y is the output and R is the noisy input. Remember, it's not any random, it's input. Okay, so the formula for RY var from the previous video, we know that this is equal to Yn convolution of R minus N. So this is the formula for cross correlation, and now we have to put this value here, then we will get Hn convolution of Rn. And now let's focus, what is this? This is actually something like correlation, right? And what kind of correlation is this? As this R and this are the same, so this is the auto correlation function of R. And what is R? R is the input, and this input is noisy. This is actually noise, this is actually the pure noise. So we can write that this is actually the auto correlation of R. Okay, so now we have to change the domain. We have written here N, but no, this is not N, this is actually L. These are not time domains, these are actually L. These are L, 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 and also RY var is a function of L. Okay, so now let's see. So this is my formula. Okay, so now we have a auto correlation of noise. So from the previous video, from our experience, what do we know? This RR, which is the ACF of, in this video we will use a white noise. So ACF of white noise, how the ACF of white noise looks. So from the previous video we see that this is L. We have a great spike here at L is equal to 0, right? But we have so small values, we have so small values other than 0. So that means this function is not a delta function, but this function looks like delta, right? You have a high value here but very small value here, that means this function looks like delta. So we can write that R, the auto correlation of white noise, approximately is equal to delta L. So if I put this value here, so this will give you an approximate result, right? So RYR L is equal to HL convolution of delta L, and as this is an approximation, so we have to write here this sign. Now what is the convolution of this. If you convolute h or any signal with delta, it will gives you that signal. So what was in our goal? Our goal was to find the HL, right? Our goal was to find the HL, and HL is approximately cross correlation between Y and R. So let me tell you again, what is Y? It is actually output, and what is R? This is the input, and this input is equal to noise, the white noise. So you somehow have to find the cross correlation of output and noise, then you will get the impulse response of this function. So in this video we have used this. In this video we have, let's say we have a system, and this system is represented by a difference equation. This difference equation is this. This difference equation is this. So let's start our code. So first of all, step 1, I have generate and white noise. So by this lines I have generated white noise, and there are 5,000 samples. You can change this by yourself. Okay, now so this is our difference equation. So we have white noise, which is our input. So we have to input the white noise. We have to input the white noise, which is R, and now we have a difference equation of this system, which is yn plus 0.6 yn minus 1 is equal to xn. This xn is now the noise. So instead of x, let's write here R. So okay, 1 minute. Okay, so instead of x, we have to write here R. Okay, let me write here x. Okay, so now it's x actually. Okay, and now we will get an output. So we have to find this output, and we can do this in two ways. So the first way is using filter function. So what we have to do, first we have to put the coefficient of the right hand side, which is x, and x coefficient is 1. And secondly, you have to put the coefficients of y, and this is actually 1 and 0.6. And then you have to write here the input. And for my case, this input is actually R. And if I use this built-in function of MATLAB, I will get what I will get? I will get y. So by this simple code, I have find the y. So if I run this thing, so this is actually the noise, and if I run this portion, so this is also the noise. So as input is noise, so the output y is also a noise. And we also find y manually. By building this equation. Similar method, by using this equation, we manually find y to check that our answer is right or wrong, or filter is working correctly or not. Let's do one thing. So let's do another thing. Y, let's write it y manually. Okay, now let me run this code. So this is y manually, and this is y using filter. So I have found y using filter. Let's take one value, and let's take one value from my manual approach, and you see these two answers matches. That means our manual code is right, and then here and then here. So our manual code is right, it's matched with the built-in function. Okay, so whatever you want, you can use you have to find the y, and how to find y manually, I also have a video in this playlist. You can check that out. Okay, but this is not the important part. The important part is here, finding the cross correlation function of y. So first of all, to find the cross correlation function. So here, so HL is equal to the cross correlation function of output and input. So simply I use Xcode, the built-in function. I find the cross correlation between Y and R and find the impulse response, as the cross correlation of Y and R is approximately equal to H. So this is actually H, and then if I run this portion, then I get the approximate impulse function by using cross correlation. Using cross correlation, I have found the approximate impulse function. Okay, so I have another way, I have alternative way to find cross correlation of Y and R. And what is that? This is simple. This is actually how can I find R, Y, R? This is the form using the convolution formula, Y L convolution of R minus L. So if I do this, I can also get the R, Y, R, L. So here I have made this thing, and if I run this code, I will get the similar result. So this is using the built-in Xcode function, and this is by finding cross correlation using convolution function. Okay, now we have to verify our answer is right or wrong. So now we want to verify finding impulse response using filter. That means we now want to verify our answer is right or wrong. So let's verify it. So how can we verify? And to verify our answer, we need to learn the theory of what is actually impulse response. So let's say our system impulse response is Hn. So if you input Xn, then simply you will get Yn, right? But if you input a delta function, then what you will get? You will simply get Hn. That means it's another way to find impulse function. If you pass you have a difference equation 0.6 yn minus 1, then xn. So now if your input is delta, you will find the impulse response h. So this is another way to find the impulse response. So again we will use filter, and we will first write the x coefficient and then write the y coefficient, and then we will input a delta function in my filter, and now I will get a h, and this h is obtained by filter, by using the matlab built-in function filter. So I have to now input delta function. So to verify this, so I have first generated delta function here, and then I just input this delta function here. So I have write this delta here, so I get h by filter, and then if I plot this cell, so I get the impulse response. Okay, so this is the impulse response using by filter, and this is the impulse response using cross correlation, and these two look same. Though the values will not be perfect, and you see I haven't normalized this cross correlation. Okay, let's normalize this. To normalize this, I have to divide it by maximum of h, so this will get normalized. So you see now this value is from 0 to 1. Now this is the approximate impulse response, and this is the actual impulse response, and this looks like same, but though the answer will be not so perfect. See, there is some difference here, because this is approximate and this is the actual using filter function, but that's not a problem. In this video our goal was to find the impulse response using cross correlation, and we have done. So thank you.